So the next item on the agenda is a panel on the science of CyberGIS. So it's kind of a complement of the one we had this morning on science with CyberGIS. We have 6 panelists. If I could ask them to come forward. The Supreme Court -3.
One day to rest in a week.
I'm going to go ahead and move this over for the video. We're just going to sit them down and get them.
Yeah.
Okay. This is the video microphone.
We certainly don't need introductions at this point in the meeting, but let me just run down the line. Nancy, Dawn, Luke, Lynn, Tim, and Xiaowen. I wanted to, I put a set of questions on the screen, and the panelists have all received them, but I wanted to make a couple of points before this starts. And the first of these is something that has come up a few times in the past, and that is the question of what is the defining characteristic of CyberGIS? When we think of the science of CyberGIS, what is its defining characteristic, and how does that influence the kinds of answers we might come up with to these questions? And what we inevitably think of when we ask what's the defining characteristic is space, or geography, G or S, the existence of coordinates, the importance of coordinates, the importance of spatial analysis. All of this raises spatial to the level of being special. But I think there's an alternative view, and that might help us through the next 45 minutes. And that is that perhaps the defining characteristic is not necessarily coordinates, because these days coordinates are everywhere, and it's very often hard to argue that there's something special about a table that has coordinates in it. But instead, what if the defining characteristic is integration? And by integration, I mean specifically integration within the spatio-temporal framework. That, I think, gives a very different perspective. This is a point that's come up, as I say, in a number of conversations in the past. It came up this morning when somebody cited something I wrote recently. It's just a little throwaway, but it does talk about the science of integration, and asks whether there are a set of principles that can be used to integrate data, integrate software, integrate. And clearly that's very central to this project, where the word integration occurs all the way through the project and occurs in the program that funds this project. So perhaps that's a different perspective on this. Is the science of CyberGIS more to do with the existence of coordinates and spatial issues, or is it more to do with integration? And that perhaps gives us a different starting point. The second point I wanted to make is that I've been beating on this question of discoveries, and whether we can point to discoveries that would not have been possible without CyberGIS. A different perspective on that. I posed this question to a number of people a couple of years ago when we were asking people to review progress in GIS science over the first 20 years. And Mark Armstrong from University of Iowa had I thought, particularly insightful comment when he said, perhaps it's not so much about enumerating the discoveries, but about the discovery of the field. In that sense, this is a transformative exercise because we are discovering something new, CyberGIS, and discovering all of its ramifications and all of its attributes and all of its complications. And that perhaps is the biggest contribution. He was making this point, of course, in the context of GIS science, and saying that perhaps the biggest contribution of GIS science was the discovery of GIS science. I think that's an interesting perspective, which perhaps, again, could cover this conversation. So with that said, I'd like just to move down the panel. And would anyone particularly like to go first? Or should we go by seating order? And should we start at the left or the right?
Just a second to get in the way.
Or in the middle.
Or in the middle.
Shawen, you've just been
I'll
on the
go for
spot.
it. Thanks, Shawen.
Nancy, would you like to go first?
Sure. So I came at this from a little bit of a different angle than what Mike was just describing. So I assumed that the answer to the first question was yes, otherwise we would have been merged with the panel earlier today. And when I thought about the nature of the science of CyberGIS, I was assuming that there already was a science of GI science per se. And so I was looking at this from what's different about the cyber aspect. And so that makes me think about other domains where cyber is also a very important aspect. So astrophysics, climate modeling, also things where you're using high performance computing. And there's a lot of issues around that, and especially issues that have come up recently. So there's things like, Eric made the nice analogy to bioinformatics, which is also another field where this is coming up huge and new recently. And in a lot of these fields, especially that field, reproducibility is a huge issue. The Galaxy framework, if any of you've heard about that for bioinformatics, it's really popular because it allows people to reproduce workflows. There have been some studies done recently about how very little reproducibility there is in scientific publications, and also, things going forward where you can tie an online paper to the data that was generated, to the input data, to maybe the ability, probably not live, but some kind of description of how you could recreate those results and maybe tweak them to look at something else. So I think there's a lot of that that comes into play when you talk about cyber and things like that. That might be enough for right now. But I think there are things to be learned from other fields where this is already very much a part of the kind of accepted way of doing things. You're modeling the simulation of the galaxy. You don't have any real data for that. It's all computing. And so what does that mean? What assumptions went into making your models? How accurate are they? How well do you remember those assumptions when you're making your final conclusions? So those sorts of things came to mind for me from a computing perspective.
Dawn?
I had a similar understanding of the what is special about CyberGIS is the cyber part. And so Nancy's comments are resonating with me as well. And in our discussions, I'm wondering whether to equate the functions of CyberGIS that Xiaowen has already described, whether to equate those as the principles of a science of CyberGIS, because these functions that he's talked about, the accessibility, the computational capability, the reliability, the interoperability, these seem to me to be computational functions, but also these are principles of what makes CyberGIS so effective. And given that we already have this established science we already have the established GI science, it seems to me I would rather not have to go through all of that for CyberGIS if possible. And can we just focus on the cyber part? Because that, to me, is what is new. That is what is exciting. That is what we have seen as making it possible for some of these scientific questions to now be answered, which is what we tried to focus on in the last panel session. So I guess I'm throwing a question back. Are these functions, or can we make these functions actually principles? They're operational principles. And to me, because we are talking about cyber, I think that's acceptable. At least that's my understanding. Also, in the first, is the science of CyberGIS distinct from science with CyberGIS? Maybe not at this stage. I remember, Mike, you and I, in our paper with Jim Proctor, we mentioned that the science, GI science, can be both. I recall that, but that was well after 1992, after you and Luke and many others had laid the groundwork. But since CyberGIS is new, maybe we can focus right now on these principles, these cyber principles.
Rats, I thought I was going to get you to write another paper on food versus science.
Well, we could, but.
There's a recent one, right?
But,
You're a retirement specialty. You should.
Yeah, well, I didn't do my homework. I, for some reason, didn't see these questions shortly before the session. So, but I did think about this quite a bit, and I'm a little bit uncomfortable with the notion that CyberGIS is somehow a separate science. I see it more as stressing the third and the fourth dimension, if you wish, the computation and the big data, and making that a new focus and a new core of the way we go about addressing questions. And in a lot of ways, as I mentioned yesterday, I feel that we're in a similar situation that we were in the late 80s, early 90s, that here's this tool, which is incredibly powerful, but in some sense, and don't take this totally literally, we're looking for a purpose for the tool. So we have this incredible computational power, but to some extent, our questions haven't really scaled up to that power. And we're still asking basically the same questions, or as I said in another talk about big data, the same questions on steroids. So it's fundamentally the same question, but now instead of looking at 1,000 observations, you look at 1,000,000 observations, but it's still the same question. So that's not really the point. I think the point of combining this computational thinking together with this incredible amount of empirical information in the data is that we think about complexity, and we think about something that was a buzzword, a long time ago, integrated modeling. So the key is integrating different pieces of models, which are really conceptualizations of how the world works, and then making them somehow talk to each other, so that, in a sense, the human is taken out of the equation, and you use the computing power and you use the computer to do that type of work for you, which of course raises the issues that we've mentioned before a number of times: interoperability, metadata, provenance, replicability. All these things go with that, and I see that as a driving force in CyberGIS science, if there is such a thing. And in terms of the disciplines, unavoidably, no discipline can claim this, and so unavoidably we'll be working at the interfaces and at the edges between disciplines, which is potentially exciting but also potentially very frustrating, because one of the things that I've experienced through my career is that the same thing is called something different in different fields, and you don't necessarily know that until you're halfway through the project. And so this is a real challenge in integrating fields like computer science, machine learning, statistics, GI science, all concerned with similar questions, but approaching them a little bit differently and using different vocabularies and different terminologies. So I think this is a real challenge in this arena, but also a great opportunity, because finally, I'm one of those people who did work with punch cards. Finally, we have this tremendous power at our fingertips, and we should find the opportunity to really exploit it and move things forward.
I'll try to address a couple of the questions. The first one is a science of CyberGIS, and it has to be a science about CyberGIS, which would mean that there are fundamental characteristics of that science that really aren't explained in other areas. And maybe that's not the case, but maybe there are some of those kind of things, determining optimal partitions of geographic space that would support multiple processors on a supercomputing system and balanced workloads, all based on the spatial characteristics, might actually be a scientific problem of CyberGIS. If it takes a parallel to conventional GIS, as we have seen it over the last 40 years or so, then there's probably going to be a commercial sector of CyberGIS which hasn't arisen yet. So that's something to think about is there a parallel to GIS and GI science between CyberGIS and if there is a CyberGIS science? And then I guess maybe the last thing I'd try to address is, are there emerging principles? And I would say not yet. It took a long time for a few principles to emerge out of the geographic information systems work that took place from the early 1960s up until the 1990s before it was actually coined as a science. So I think we're too close to the infancy stage of CyberGIS for those principles to emerge at this point in time. But it may happen. I'll leave it at that.
Thank you. Tim?
Mary, do you have that component architecture slide for me? Thanks. So in the early 80s, I came to know GIS as a data integration engine. So it was integration was a key issue. I challenged my students with the idea that this GIS stuff is about database management. It's about visualization. It's about spatial analysis. There are technologies, whole technologies, sectors of the IT world that are working on these things. But yet, GIS, the stuff that we do, it puts it all together, or at least attempts to put as much of it together as possible. I challenge them and say, give me some other sophisticated platform in the world out there who claims to be doing more integration than we're doing. By nature of the same issue, I go, this stuff is about space, it's about time, and roughly it's about attributes. That's space, time, and attributes. You know, the attributes is the other. And I'd say find the fourth category, other than other. Get into a discipline where there is something whereby when you do work, you'll write papers and a Nobel Prize is at the end. So that space, time, and attribute is all stuff in the world, imaginary versus whatever it is, and we try and integrate that stuff together. So when I saw this component architecture, it's called an integration architecture by the nature of the label that's there. It is in the proposal. It is out of Xiaowin's 2010 paper. And when I saw this, and then I saw Luke's slide, Benoit's slide probably, yesterday is what it was, I go, there's the framework I've been talking about for this last year to get this guy to start a paper in draft form so that we can actually put a paper out about the integration strategy. So it's moving forward. I'm very fortunate here to see that there's actually something out there. So this integration stack. So Luke called this, when he sent it to me, the integration stack. And indeed, phraseology, if we go back to the other one. So this is one column, one might say, or the general column across all of these. So the challenge here in terms of the science perspective, of the science of integration, this is the science of data, information, evidence, knowledge, wisdom, and truth integration. Now, it's great that Mike didn't put any of those in front because there'd be a string of 5 of those. They appear on page 13, isn't it? You know that page? But I know that's probably Ryan's. That's Ryan's framework that appears in the textbook on GI systems and science is what it is. So it's all of those together, of course, that we're after here. So any one of these components could be integrated to any other component. And the interesting thing is, you ever hear this this term hard-coded? What if you just hard-code everything? There's no changing in this. It runs like crazy, right? Nanoseconds, and the nature of the problem probably won't be very sophisticated, or that's the only problem you can solve because it's hard-coded. The thing is that we don't want much of this hard-coded at all. We want all of these components to come in that are plug-and-playable and go from the, we'll say the bottom of the stack, the foundational or upper ontology layer is what I call it, up to the application layer. But of course there's a difference in terms of the different idea in those terms that are out there. But getting at this issue of the science of CyberGIS versus science with CyberGIS, it would be my contention that the bottom of the stack is all about the focus of the science of CyberGIS. But as we move toward the top of the stack, that's about the science with CyberGIS. Now we know that we can't do either one of those without the other. And that's the point here, is that we come into here with some problem focus, probably in terms of the science with CyberGIS, and hoping that there's something to use out there. There's something stable out there in terms of software, large distributed resources, and so on that we could take advantage of. Whereas on the other hand down here, we're trying to build this stuff down here, hoping that the problems aren't going to change too much, maybe, by the time we get this thing built, so to actually do something for someone. But of course, it's in the mix in between here in terms of meshing between the problem focus and the technology focus to figure out what it is that we're doing. So from a science of integration perspective here, I think this project's trying to sort through what are all the integration protocols from each pair of the rows as each pair of the columns, as it would be taken to in pairwise fashion if one wanted to go at this systematically.
Thank you. Shall we?
Yeah, I'll start by commenting on what you started with, a comment. I think there are 2 points you brought up. One is, does adding cyber ahead of GIS have major ramifications as to the scientific character of GIS science? My comment is possibly. I'm not using the progress in CyberGIS directly. Let's look at the broad picture of the major changes in science and engineering in the past decade. So the notion of fourth paradigm, digital explosion. I think, broadly speaking, the science and engineering context, people start to recognize, as I mentioned yesterday, it is business unusual. So there are some potentially major leaps forward. Whether that is the case in the context of CyberGIS, I think we need to have more evidences to be able to demonstrate that unique character. But I'm hopeful there are substance there as we're making more progress to show what is that unique character, whether that is going to speak to a dramatic new direction of science. In terms of the second part, I think resonating that in CyberGIS, the G is an important element. You know, why spatial is special. That's almost a part of article title of Luke's publication, very early 90s or mid 90s. So I think the spatial principles, thinking, understanding, will continue to serve important lens of the science of and with CyberGIS. So that's my response to what you started with, Mike. And the first question, let me add to what's shared so far. I think the science of CyberGIS and the science about CyberGIS, science with CyberGIS, it seemed to make sense they are organically together, given the spirit and I would say first order principle of CyberGIS is about integration. So I think the way of dividing between science with CyberGIS, science of CyberGIS, seem to violate the spirit or first order principle you might sense in terms of integration. I think it's more healthy to consider them holistically together, although we separate the panels and try to articulate different pieces, but I think they ought to come as a holistic piece.
Very good, thank you. So let's open it up. There are at least 2 questions on the board that haven't been addressed really by any of the panelists. And perhaps you also have comments on some of the other questions. Or perhaps you'd like to pose some different questions. So let's just open it up for the remaining time, which I guess we have about 20 minutes.
Maybe a naive question. So when we say CyberGIS, because GIS, this acronym could be Geographic Information Science or Geographic Information Systems. When we talk about CyberGIS, which one we are talking about? What kind of cyber geography information systems or cyber geographic information science? I mean, you guys.
I could say something. Oh, go ahead.
I was just going to say, I think without question at this point, it's cyber geographic information systems. And part of what this panel and the previous panel are addressing is whether or not there is a cyber geographic information science.
Yeah, so in the paper, it's short, maybe longer, a few different versions I wrote about this is the definition so far I saw from the literature is like a geographic information system based on advanced cyber infrastructure is what CyberGIS, how CyberGIS is defined. Again, I don't think this definition is rock solid, and in fact, I'm working to refine what's projected. It's a different, okay, so I thought it still projected the diagram. Tim was talking about it, so I did not respond to the question he posed to the audience yesterday about the dimensions. I think that framework is evolving. The building blocks, as I thought through 2009 or 8, in fact, that diagram, I believe, was coming out of my NSF career proposal. So that was about 2007, 8. Now, by the time published, 2010, and we were writing proposal, did a little extension. I think a lot of things have actually happened since then.
I have to say there's at least 4 ways of decoding the S. We started with systems, and then we went to science, and then studies, and now just plain stuff. So we're working on a 4th edition of the textbook right now.
Yes.
And we made a decision that throughout the textbook we would never use GIS. In every instance we would decode the S as appropriate. Because what's common is GI through the whole thing. But the S varies depending on the context.
You know, many years ago, when GIS was used, it was considered as a tool. Like in the 1990s, you coined or created the word GI science. At that time, so maybe GI science was evolving or developed from GI science, the so-called quotation mark tool. Maybe today we may have the same situation.
There are 2 other S's as well, in addition to, so society has been published, and then services. So if you look at, Peng and Su's Internet GIS, that the services term in there is full, big, front and center. So those 4, normally when I deal with it with the students, it's science, systems, society, and services, all in a very meaningful way. They all have something. So the S is by convenience, right, that we don't actually, if we wanted to deal with them all.
And that was partly also to deal with what I see as quite a significant trend, which is that many, many people in this field don't recognize the acronym GIS. They see it as very, just one of many, many terms, and perhaps the most generic term is geospatial.
You joke like a global, international something.
Yeah.
I know S is not a school.
Doesn't it stand for Graphical Information Systems?
Oh, I like global.
Global information science.
Actually, I like that comment. So my response to this question is the emphasis is on cyber, not on GIS. GIS is already very well established. So what we are talking about here is not either GIS system or GIS science, but on cyber. Cyber is the new thing here. So we're talking about the science or not science, about cyber part. And for cyber, I think it's the network, right? It's basically it's a way to approach. It's a way to approach things. And what I see the cyber approach, 3 things. First, people. The contributors, the data contributors or model contributors, people or users. So through network, we have a better way to approach them. And people can approach whatever you have here. This is the accessibility or interoperability, something like that. So anyway, it's a way to approach people, or people to approach it. And second is is a resource, computing resource. So you have this network, you have the cyber infrastructure, so that you can approach more resource. You can integrate more resources together to do larger, bigger, and very big things you cannot do before. And the third is the methods or models that I just said. Through networks, through the cyber infrastructure, you can approach models of different uses, different methods at different places from different people and integrate them. So this is what I see this cyber thing, what the cyber thing brings up to us. And I don't know if there's a science in this or not, but this is just my understanding of what cyber bring to us.
Since we're discussing the work, I want to share my impression from yesterday about the CyberGIS as a word. I think when they came up with the term cyber infrastructure, the focus was on infrastructure, and the cyber was just saying it's a virtual computer-based thing. So in case of CyberGIS, I think GIS kind of already has the computer virtual thing in it. So it should have probably been GIS infrastructure rather than CyberGIS, because I think that's what you want to accomplish. You want to build this infrastructure that includes the code and data and interface and community that would basically be useful for various sciences, including GI types. So that's how I understood it, but I might be wrong.
So I was trying to think of the what's the nature of the science of CyberGIS, and maybe trying to move a little bit away from the semantics of it. I guess I would think of it as cyber geographic science, whereas cyber and information are sort of similar, but it needs to involve effectively formal models for geographic objects in cyberspace or in computers. It needs to involve defining abstractions, it needs to involve vocabularies, it needs to involve advancing methods, solution of problems, the generation of knowledge, and understanding involving digital representations of geography. The principles need to address spatial relationships, patterns, multi-scales, many of the things Xiaowen had in his slides. But I mean, I think if you put all that together, you could probably craft a definition of what would rise to be a science.
Any comments?
Yeah, I'm wondering if the term scalability, with all of the multi-dimensions that could fit under scalability, is actually a covering term for the three comments that were mentioned. So the infrastructure stuff, there's something in scalability. I think, Shun, all of the comments that you made, but there are multiple dimensions. You mentioned multiple dimensions of scalability, and that's something that Xiaowen mentioned. It's something that I also had in a human way. So it's from few people to many people is a scalability thing, as is computing resources from smaller amounts of computing resources to large amounts of computing resources, no matter the kinds of resources that one would use, because there's lots of different dimensions of resources that one could bring in to that picture as well. So the issue still resonates with me. The scalability issue here is really what distinguishes the current thing that we're doing versus what we might have been doing before. And so David as well, with all of those that you mentioned.
I was thinking of scales in terms of mostly physical and process scales, but it's certainly algorithm scales, scalability is part of it too.
But is there any such thing as infinite scalability? Doesn't scalability simply mean more scalable than before?
Yeah, and so this is the thing that Piotr keeps hammering on me. Well, Tim, the stuff we're talking about now in terms of the cyber and the high performance, that's going to be passé in 5 years. So, you know, what else are you doing new?
Well, I guess you get back to the philosophy of fractals. I mean,
Yeah.
there's always only a range over which you have a fractal.
Yeah.
state.
Or big data is merely bigger than before.
Yeah.
Yeah, it's,
Perhaps-
go ahead.
I was going to go to another question that
Sure.
hasn't
Go
been
ahead.
touched
Yeah.
on before, and that is how should progress in the science of CyberGIS be measured? And I might suggest that one of the ways that we could look at that type of measurement is through the user interface and the ease of use and the accessibility of CyberGIS. So that might be a measure of the success of it as a science.
And certainly a metric that NSF would be responsive to.
Yeah, and as part of the proposal, we shared with the community that what you brought up is included.
Andre, did you have a
Yeah, so following up on that, so it would depend though, answering that question, how should it's measured on delineation of what is CyberGIS versus what is not. Which relates to the question of the coordinates versus integration, where there is no versus. Integration is the purpose, but it's enabled by coordinates via which phenomena are expressed in a common reference system, so that they can be and that question, once we have a space within which all of these activities can be expressed, then progress, or I should say change, can be expressed. And you'll see an example of that in my lightning talk.
I like this way of framing it, because with this greater accessibility, as Lynn has mentioned, then you're going to have more people using it and adopting it, and it seems to me that that would be a measure of progress.
I thought for those last two questions, what we have an area in Exceed called Novel and Innovative Projects, and that's where we work with groups who typically haven't used supercomputers previously, but the amount of data that they have and the digital nature of that make them kind of new users, so digital humanities and analyzing the handwriting and census data, and there's a lot of GIS examples. So what we'll typically do is look for someone who's a leader in the field, who's gonna really change things because of the fact that they've used high performance computing. And you're not sort of talking someone into using it just because you want them to use it, but it's a more realistic simulation. Maybe you're uncovering patterns that weren't uncovered before. And so once that person's publishing and kind of respected in the field, we'll see other people kind of gathering around until it becomes an accepted way of doing things. And I think that when we say how should progress be measured, I also thought of the usage question. Also, I had that in some of my my typed up responses, but also I thought when you have these leaders, now there's a need to teach that to the new students coming up. Now they have to know about that to really be part of that field. And so that to me would be a measure of progress, when it's seen as, well, you can't get a degree in this without knowing about this aspect of it because it's so important. So a couple more.
Knowledge aspect, right?
Yeah.
Particular comment.
I think another aspect of measurement of progress is the extent to which the scientific community changes its behavior, in particular in the social sciences, which still predominantly are single person type of investigations. And so when we see a movement away from that towards using the cyber part, which enhances collaboration, enhances distributed data, distributed computing, moves you away from your little cubicle or your little desk towards engaging a community. I think that would be a critical measure of the extent to which scientific investigation has actually been affected by this infrastructure.
Well, when I look at the word CyberGIS and its measurement, in terms of semantics, I have a picture in my mind. So there are multiple computers, in a certain space. Could be the globe, could be some local space. Then in front of each computer, there's one or a few users or persons. Then throughout a certain internet or web or network, then all these people are connected with each other. So inside, behind, that we cannot see, using our eyes. We have computer scientists, we have, geographers who contribute to the software, the hardware, and so on and so forth. So in this way, I would say, for measure of success of CyberGIS, on the one hand, yes, we need as many users and, a great accessibility. But on the other hand, I would say like software would be very important. For example, the interface between the person and computer. If it's very hard, it's all like share, like you computer scientists, it's all share based, like no matter it's in DOS, what's in, whatever Linux terminal. That's not very user friendly. That's actually the work of computer scientists. But for the 5 million people, 5 million users or normal citizen, so that we need a great interface between the computer and the person. Well, on the other hand, like as Srin just mentioned, resources, what kind of geographical information we have, how we can use different data models to represent or present the data into this information system. So I kind of think about a picture of multiple computers, multiple people, person, computer, interface, and the software behind, or batteries, the network and the system.
I laughed at that because I was thinking when Jan was doing his demos, I'm like, to get to where Mike was also talking about this usable, ubiquitous to all, like we have to break computer scientists of their habit of DOS and the terminal and CBS files, and like we're just like used to it, so we don't even question it. We're like, yeah, that's just how it is. I have to read this like really difficult text file, or I have to look at. Actually, I really like that in HydroShare. Seeing some of the things that you can download from the EPA as TXT files that are very difficult to read, they're much easier to understand in HydroShare. One of the examples you had was like, I might use that just so I can understand. I mean, I can read the EPA's text files, but I've actually wanted to share them with others. And I think there's like moving a whole community of computer scientists maybe away from that low-level way of interacting. And I don't know if that's really what we want to do, but I feel like we kind of need to get that group of people engaged in developing better user interfaces. And I don't know how to do that. It's kind of like, well, this is what I'm used to, so you can learn to deal with it too. I don't know. I'm not sure. Like maybe if we change how computer scientists interact with the machines and make them think about more user-friendly ways, then it'll become more user-friendly. I'm not sure.
Sure.
It's just a thought.
Yeah, to pick up on that point, I think most of them would say that is the best interface. We talked about partitioning and divide and conquer. Our institutions do that as well. I mean, that's why we run against these silos. And I think under the infrastructure part, we need to pay attention to that. And I was struck by David's comment this morning about the Open MI initiative, which is apparently very successful in hydrology. So I went to the webpage about the projects that have been, I guess, approved or are using it. And they're all hydrology, even though open modeling interface seems to me something that should cross multiple domains. So why is that? Why aren't we there? I think it's this issue of these silos that are sort of the elephant in the room. Maybe we're all on the same page, but our colleagues in these other disciplines, maybe not so much. And I don't have an answer to that. I just wanted to point out, I don't think we're spending quite enough attention on that.
Mike, you got a person.
Oh, go ahead. Go ahead.
I'm interested in the first question, the science of CyberGIS and the science with CyberGIS. So try to answer the first question, I think. So when you think about what is science, so science is using some scientific approach in search for truth. So what the truth we are looking for using CyberGIS. And from my understanding, maybe based on what we learned yesterday and today, maybe we are looking about some approach for integration across some different data sets and also different models, how to enable in CyberGIS. And the second, for the science with CyberGIS, maybe we are thinking about maybe for some, for example, global climate change study for the hydrology. Maybe can we answer some question cannot be answered by previous study without cyber infrastructure? Maybe that is the science with CyberGIS. So just from my understanding.
Thanks for sharing that. I want to come back to what Mary brought up. It's interesting search follow-up. So that's the best interface.
Some of them would argue that.
I think this is actually the nature of CyberGIS. As I have been arguing, it is a spectrum. And it's an ecosystem, and you cannot only have just folks appreciating black boxes. You have to also have folks messing up with black boxes. This is why I refer to the history. If we don't have those pioneers messing up with punching cards, Luke nodded, not telling your story, messing up. But probably I should pick up more positive word. But that's positive word. So that's the time here. There's creation and innovation have to take place, and we're doing that. And at the same time, I show the spectrum. We get to the citizen science long tail part. You got a massive users, 5 million, what have you there, any number you pick. But there's spectrum in between, and that's where we might interoperate with HydroShare, because that's the interfaces into the ecosystem to understand how, in a healthy way, different pieces come together to deliver their values and understand each other's values and how should this integration come together. So I think in this rapid change, we definitely want to appreciate that spectrum. And if we don't, we actually ignore parts of the community, or big part of community. We might, because of the ignorance, we miss opportunities.
Even in this classroom, based on Darwin's curve, and I think we wrote several, computer scientists, they may on the left-hand side, and we have many applications, users, then which should be located or distributed on the right. Well, when I was talking about the interface, I had no way or had no meaning to downgrade or depreciate, the contribution from those, black box, you call it.
Black box.
Yeah, black box, people, computer scientists, coders. Because 10 years ago, 11 years ago, when I started ABM, I actually took a course from computer science. I spent lots of time doing that. I know it was difficult for a regular, say, geography major. So we do need a spectrum of scientists with different expertise, specialties. And when we come together, it's a CyberGIS community. I think so when you did a great sense of you invite this spectrum of people, which kind of represent your curve.
It's not curve, it's everybody's curve.
We're up into break time. Would anyone particularly like to have the last word?
Sure, I'll have the last word and say that Tim's hard coding was when we did it with punch cards. So.
Okay, let me thank the panel. I think
Thank you
we've
much.
shed some light, even if we haven't necessarily closed the discussion. And thank you for the questions and comments. And let's celebrate.
I wonder if